Okay, this is the P4 paper from October 2020. It's question number 3, which is an integration question, and in particular, it's a volumes of revolution around the x-axis. So I'll just draw on the diagram to explain what we're doing. You don't need to do any drawing on the diagram, but we've basically got this shape R, this region R, which is going to be rotated around about the x-axis. So what that means is that this shape here then is going to be formed where, if I try and do a little bit of 3D drawing on it, it turns into sort of like similar to a bowl type shape. Now you don't particularly need to do that. All you do need to know is that the volume of revolution is always given by the integral of pi y squared dx from A to B, where this value here, this value here is going to be A, and this value here is going to be B. Well, we know what A is. A is going to be equal to 0 there, but that B, I've actually got to work that out. So in terms of the examiner, that's the first thing I'm going to do, is I'm going to say, okay, to find the limits, we can just state A, to find the limits. So A is equal to 0 straight away, but for B is going to be where this curve is equal to 0, where y is equal to 0. So again, that's nice and easy to do. Just show the examiner what we're doing here. So for B, y is equal to 0, which means e to the 0.5x minus 2 is equal to 0. So I've just got to solve this equation. It's a straightforward one. We get e to the 0.5x equals 2. At that point, I can log both sides. That's how I'll get rid of the exponential, by logging both sides. So I'll get, just do it straight away, 0.5x then is equal to log 2. And from that then, x, divide by half, or divide by half is the same as times by 2. So I'm actually going to write it down as 2 log 2 there. So in other words, b is equal to 2 log 2, or rather than the original volume that we had is pi y squared dx between 0 and 2 log 2. I'm actually going to put the pi out there now just to make it easier for the rest of my work. Pi y squared dx, I just need to work out what y squared is. So just take your time, don't rush through this. 2 log 2, 0, we've got e to the 0.5x minus 2 squared dx. So if you do a minus b all squared, don't write this in, this is just me explaining to you, it's going to be a squared minus 2ab plus b squared. So in this case, that's going to be, again, between 0 and 2 log 2. It's just thinking about what a squared is, what that first thing squared is. You've got e to the 0.5x times e to the 0.5x, or you add the powers there. So that's going to be e to the x. The rest of it just sorts itself out. 4 lots of e to the 0.5x plus 4 dx there. So it's that thing that I've actually got to integrate. So if I'm integrating, when I do that, this obviously is going to change to a square bracket now. I'm going to be doing something between the limits of 2 log 2 and 0. Or the integral of e to the x is e to the x. The integral of e to the half x, what you'll do is you'll divide by a half. And dividing by a half is the same as timesing by 2. So that's going to become minus 8 0.5x. And then the integral of 4 is just 4x. So just take a little bit of time over that bit there. Just be careful when we're doing it. Right, we've got to put those values in then, 2 log 2 and 0 in. And again, I'm just doing everything really slowly here. So I'll continue to do that. So it's e to the 2 log 2 minus 8e. So half of 2 log 2 is log 2 plus 4 lots of 2 log 2. And again, 4 lots of 2 log 2 is going to be 8 log 2. So it's that bit minus, now this other bit isn't 0, be careful, you've got e to the 0. Well, e to the 0 is 1. You've got minus 8e to the 0. Well, 8e to the 0 again is 1. But here we get plus 0 there. So just tidy this all up. What I am going to do it just changed that one there, 2 log 2. I want that really to say log 4, don't I, rather than say 2. If we've got 2 log 2, that can just go up there. The power can go up. It's log 2 squared, which is log 4. Hopefully that isn't causing anybody any issues. So I've got pi e to the log 4 minus 8e to the log 2 plus 8 log 2. All of that minus that's going to be plus 7 there. But then these bits, e to the log 4, pi in, e to the log 4 is 4. E to the log 2 is 2. 8 lots of that is, 8 lots of 2 is 16. The 8 log 2 part there I can't do anything with. And then the plus 7. So this should all now tidy up to just an exact answer that's quite neat and tidy here. I think I've got 8 pi log 2 and then those numbers minus 5 pi. So I think that's my final answer. Let's just go back. Yeah, and it does say write it in that sort of format. So that's what I've got there, and A and B are the 2 constants that I found. Relatively straightforward. Just be a little bit careful about some of the fussy stuff with the exponentials and the integrating them and then putting the logs into exponentials. But hopefully all of that makes sense to you.